Good morning. Now we are going to see the topic laser. Laser stands for light amplification by stimulated emission of radiation. It is a device which emits powerful monochromatic, collimated and coherent beam of light. Characteristics of laser: highly directional, high intensity, monochromatic and coherent. These are all the characteristics of laser light. Theory of laser: consider an assembly of atoms in a material which is exposed to light radiation. Three different processes takes place when light radiation interacts with the material. First one, induced absorption. In the induced absorption, an atom in the ground state absorbs an incident photon of energy h nu and is excited to higher energy state. The rate of induced absorption is given by R12 is directly proportional to rho v n1. Further, it can be written as R12 equal to B12 rho v n1, where n1 is the number of atoms in the lower energy state, rho v is the density of the incident light radiation, and B12 is proportionality constant. These are all the images of three different processes. First one is induced absorption. In the induced absorption, atom in the lower energy level absorbs the incident light photon of energy h nu and it goes to the higher energy state. This process is called induced absorption. The second one is spontaneous emission. In the spontaneous emission, atom in the higher energy state returns to the lower energy level spontaneously by emitting a light photon of energy h nu. This process is called spontaneous emission. And third one is stimulated emission. In the stimulated emission, incident light photon stimulates the atom in the higher energy level to make transition to the lower energy level by emitting two photons of energy h nu. Second one is spontaneous emission. The spontaneous in the atom in the excited state E2 returns to the ground state E1 by emitting a photon of energy h nu without the influence of any external agency. Rate of spontaneous emission is given by R21 directly proportional to N2, R21 which is equal to A12, A21 N2. N2 is number of atoms in the higher energy state where A is proportionality constant. Stimulated emission. As we have seen in the picture, the atom in the excited state E2 returns to the ground state E1 by emitting a photon of energy h nu with the influence of incident photon. R21 is directly proportional to rho v n2. R21 which is equal to B21 rho v n2. Next, concept of laser. The image shows the amplification of light radiation due to stimulated emission. The photon emitted during stimulated emission has the same energy, phase, frequency and direction as that of the incident photon. Thus we have two coherent photons. Now these two photons get incident on two other atoms in the state E2. This results in the induced emission of two more photons. Now these four coherent photons of same energy, these four photons induce further transitions with four other atoms in the energy state E2. This gives stimulated emission of 8 coherent photons of same energy. Here, first we have one incident photon which triggers the atom from higher energy state to lower energy state. This results in two photons, emission of two photons of same energy h nu. These two photons stimulates two other atoms in the higher energy states to the lower energy level. This process results in emission of four atoms of same energy h nu. Further, the stimulated emission goes on continuously, which results in emission of laser light radiation. If the process continues in a chain, ultimately this gives rise to increase in intensity of coherent radiation enormously. Stimulated emission is multiplied through a chain reaction. This multiplication of photons through stimulated emission leads to coherent, powerful, monochromatic collimated beam of light. This light is known as laser light. Thus, for laser action, stimulated emission is most predominant. It is achieved by population inversion. Next, we are going to see Einstein's A and B coefficients. Under equilibrium condition, the number of downward and upward transitions per second are equal. Therefore, we can write number of spontaneous emission plus number of stimulated emission equal to number of induced absorption. Substituting the expressions for spontaneous emission, stimulated emission and induced absorption in equation number 4, we get A21 N2 plus B21 N2 into Q, which is equal to B12 N1 Q, which is given in equation number 5. Rearranging equation number 5, we get B12 N1 Q minus B21 N2 Q, which is equal to A21 N2. And on simplification, we get Q it is equal to A21 N2 divided by B12 N1 minus B21 N2. Dividing numerator and denominator by B12 N1, we have Q it is equal to A21 N2 divided by B21 N2 divided by B12 N1 divided by B21 N2 minus B21 N2 divided by B21 N2. So Q equal to A21 divided by B21 into 1 by B12 divided by B21 into N1 by N2 minus 1. On substituting N1 by N2, it is equal to e power h nu by kt. In equation number 7, we get Q it is equal to A21 divided by B21 into 1 by B12 divided by B21 e power h nu by kt minus 1. Planck's radiation formula for energy distribution is given by Q it is equal to 8 pi h nu cube by c cube into 1 by e power h nu by kt minus 1. So comparing equations 8 and 9, we have B12 divided by B21 equal to 1. Further, you can write B12 equal to B21 and A21 divided by B21 it is equal to 8 pi h nu cube divided by c cube or 8 pi h by lambda cube. Since B12 equal to B21, Einstein's coefficients are termed as A and B coefficients. Conclusion: the spontaneous emission is more predominant than the stimulated emission. The laser light is due to stimulated emission. Therefore, stimulated emission should be greater than spontaneous emission. To achieve this, population inversion is required. Equation 11 gives the relation between spontaneous emission and stimulated emission coefficients. Since this ratio is proportional to nu cube, the probability of spontaneous emission increases with energy difference between the two states. Last, industrial applications of laser. Laser is used in material processing such as welding, cutting, drilling, heat treatment and non-destructive testing of materials. Thank you.